Good morning, guys.
Good morning, sir.
Morning. So, by this time, you might have been informed about the first internals, is it? So, the second internals. So, when they are going to start?
27th.
27. Okay. So, for that, the portions are the second law of thermodynamics, complete theory and problems over there. And next is your conduction, heat transfer. Okay. Heat transfer complete. That is conduction, convection, and radiation. So all the three theoretical concepts and the problematic concepts. So these two will form your second internal portion. Okay. And hope you have got a post in the Google Classroom regarding variety of textbooks, the notes also. Have you gone through that? Whether it was useful? Hello.
So we have received, sir.
Yes, sir.
I had not gone through it.
Okay. So go through it. I've just collected few of the textbooks online and had few more in my laptop. So I all just clubbed those and created a post in Google Classroom. Some or the other way will definitely help you. And okay, if you're more keen into the subject, you want to solve a few more problems, you can get the data from those textbooks. Out of all, I prefer Rajput, R.K. Rajput to be a better author, writing the concepts in a more feasible and legible way in order to understand it. Rajput is better. Even Pekenag is better, but Pekenag gives you very sort of limited content. Whichever is more important, only that thing will be given Pekenag. And the language which he uses is a little bit complicated. And understanding from that textbook could be a little more tedious. Okay. And out of all Lakshmi Narayan, other all textbooks, Chandrasekhar, and Metal, all those textbooks are good. So few of the textbooks are good for the heat transfer, and few of the textbooks are good for the thermodynamic part. We have to Balasubramaniam is good for the applied thermodynamics part. So there are plenty of textbooks if you want plenty of knowledge about the subject. Okay. So whatever is taught in the class will be of more of exam specific oriented type. So whatever it is required for the exam, only those concepts are being highlighted, and rest all is being just forwarded. Okay. 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 So before moving further, we will discuss some of the concepts from the heat transfer part, which you remember. Okay, I want you guys to answer now. Which all concepts you remember from heat transfer? Okay, let's see how much of the concepts you remember. So we shall discuss this particular thing for about 15 to 20 minutes, and then we shall go for the further topic. Yes.
like a thermal reservoir, source,
Yes, Karthik.
thermal reservoir, source,
Thermal reservoir. So that is with regard to a second law of thermodynamics, right?
second
So
also.
I'm asking about the heat transfer now.
Okay.
Conduction, radiation.
Okay, so three forms of heat transfer we have discussed, which is conduction, convection, and your radiation. Yes. What else? What else? Anvit, Anvit Sirai.
Yes, sir.
Yes, man. So what do you remember from the last 4 to 5 classes? Ashwita, Benoy.
So thermal resistance.
Okay, the concepts of thermal resistance. Okay, so the thermal resistance is what? Suppose there is a material like this. Okay, one side, if you are providing a heat, okay, and if for this particular material here, if the temperature is T1, which is equal to 100 degrees Celsius, and on the other hand, if you have a temperature of 50 degrees Celsius, now because of this temperature difference, what happens? The heat gets flow like this. Okay, in within this material, if you try to analyze, okay, within this material, there is, when the heat is trying to flow in this direction, there is an obstruction for this heat flow, which is known as the thermal resistance. Okay, that value of R, that value of R is different for different modes of heat transfer, the resistance for which it carries out. So electrical analogy we have made. What is that electrical analogy? So if you want to transfer a current but a specific voltage through a resistor, so that governs that is given by I is equals to V by R, where I is the amount of current you need to pass, V is the potential difference across the ends, and R is the resistance to which the current has to pass through. The same analogy is being made for this particular heat transfer here. And this heat transfer, so Kev is the amount of heat to be passed against the temperature difference T1 minus T2. That is, you can call it as delta T even. Okay. And the resistance for which there is for the flow of the heat is taken as R conduction. So this particular resistance is for the conduction. Similarly, you have resistance for the convection as well as for the radiation. Now, I want you to answer what is our conduction, what is our convection, and what is our radiation. What is the resistance offered in case of a conduction? What is the resistance offered in case of a convection? And what is the resistance offered in case of a radiation?
For conduction, it's dx by ka.
Okay. Can I write it as L by Ka, where L is your length of the material? Even I can take it as dx according to your Fourier's law. So Fourier's law, if you illustrate, it will be dx. If I take generally, it would be length or thickness. So I will be taking it as L by Ka. For the convection. What is K, by the way? Everyone, open your Google Classroom. Check out the notes for the heat transfer, that is module number 3, which is being updated. Download it, open in a new tab, look into it, and give me the answers.
So thermal
Thermal
conductivity.
What is the value? What is K?
thermal conductivity.
Okay, I'll just write this on. Just a minute. Okay. The value of K is thermal conductivity. And what is its units?
So watt per meter degrees Celsius.
Watt per meter degree Celsius. Okay. So it has units of watt per meter degree Celsius or Kelvin. So it might be watt per meter Kelvin also. So that is the unit of thermal conductivity. It gives you the amount, how much the heat is being conducted to the material. So what is the feasibility of heat conduction through the material, that is known as thermal conductivity. Okay, that is the value of K. Anything else? L is, you already know, that is the length or thickness of that particular specimen. A is nothing but the area of cross section. So what is the cross section area of this? That is your A. Now, what is the resistance in case of a convection for the flow of heat transfer?
One divided by HA.
So it is 1 divided by HA. Now, what I'm supposed to call the H, the value of H. What is the value of H over there?
Convective heat transfer coefficient.
So I will take it as heat transfer coefficient. Okay, that is, what is the unit of this? Watt per meter is meter square. What is that? What is the
Degree
unit of
Celsius.
watt per
Meter square degree
Meter square
Celsius.
degree Celsius.
watt per meter square degree Celsius? Remember, the value of K is well by in watt per meter degree Celsius, only meter over there. But when you come to a heat transfer coefficient, which is the value of H, which governs the convection, here the units are watt per meter square degree Celsius. Keep this in mind. Now, coming to the resistance of the radiation. So what is the resistance offered in case of the radiation heat transfer? Hmm. Download the notes from the Google Classroom Look into it, see what all it is there. Give me the answers.
1/f.
1 divided by
1/f into sigma into A.
F sigma A. What else?
T1 plus T2
T1,
divided
T2.
by T1 square plus T2 square.
T1 plus T2 divided
T1 plus
by
T2.
T1 square
T1
plus
square
T2
plus
square.
T2
So
square.
this is the resistance offered in case of a radiation heat transfer. Okay, here you need to remember what is sigma. What is sigma here?
Stephen
It is
Boltzmann constant.
Stephen Boltzmann constant, and what does it spell if? What does it spell if?
5.67 into 10 raised to
5.67 into 10 to the power of minus 8
minus
watt per
meter square Kelvin over
meter
4.
square Kelvin to the power of 4. So this is the value of Stephen Boltzmann's law. Now what is F?
Emissivity.
F is emissivity. That is in case of a closed surface, I guess. What is F, by the way?
So the geometric property of the
Very
object.
good. So it is a geometric property, okay? Or you can say it to be a shape factor. Sometimes even it is called as contact factor. Okay, there are multiple names. Just remember that the value of F governs the geometrical proportions through which the radiation heat transfer will occur. So I have explained regarding this, right? How it affects the radiation heat transfer, the geometry of a surface. Have I explained or not? Yes or no? No?
So you explained.
Amit Lahari. Amit Lahari. Amrit. Amrit, so what is the resistance offered in case of a conduction?
Conduction, sir.
Yes. What's
So
the
is that
problem, man?
so the period?
There are only 30 people in the class. Out of 30 also, very few are responding today. What's the reason? Tired already? So soon?
No, sir.
And not only Ambutman, I'm not talking only to you, but for the entire class. What's the reason for your inactiveness? Omkar? Nishchat?
Yes, sir.
What's the reason, Omkar? Tired, all of you today? Not in a mood, good mood? No good vibes around you? What's
So nothing like that.
then? Sagar?
Yes, sir.
ಏನಾಯ್ತು ಎಲ್ರು ಇವತ್ತು ಡಲ್ಲಿದ್ದಾರೆ?
ಏನೋ ಗೊತ್ತಿಲ್ಲ ಸರ್. Don't know, sir. Why?
Okay. Even your internals gets postponed, I guess. It is on the 27th, right? You have 1 week more time.
Yes, sir.
Yes, sir.
Question.
Yes, sir.
ಏನ್ರೆಲ್ಲರೂ ಮಲಗಿದಾರ ಎಲ್ರು?
ಗೊತ್ತಿಲ್ಲ ಸರ್.
ನಿದ್ದೆ ಬರ್ತಾ ಇದ್ದಾನೆ ಎಲ್ರಿಗೂ?
ಇಲ್ಲ.
Ashwita, CR.
Yes, sir. I'm on the CR, sir. Chandan.
Okay, you are not the CR, sorry. So, who is the CR then?
Chandan.
Chandan,
Sir.
where he is? Chandan is not in the class, so he's a vice CR then. Yeah, substitute for the CR. No one. Okay. Karthik.
Omkar, sir.
Omkara. Omkar? Omkar. Omkar. Even
Yes,
he's
sir.
not there. Omkar.
Yes, sir.
Yasmin, so you are a vice CR. So if you are not a vice CR, I will appoint you as a vice CR from now. Okay.
So me.
Say why the class is going on dull. I want the reasons from you and what actions need to be taken so that everyone regenerates.
As college is going to start offline, so sir, everyone is bored on online mode. They are pretty interested in offline, sir. So I think.
Okay, that might be the reason. So, okay. So out of 34 people, how many of you have preferred offline classes rather than online classes in whatever the forms is being circulated? Wait a minute. Just, I will switch off the recording.